This is SP Smart School. Today we would like to discuss one of the topics of trigonometry named as allied angles. Well, in previous class we have done trigonometric ratios of 0 degree, 30 degrees, 60 degrees, 45 degrees and 90 degrees. The trigonometric ratios of these angles we have discussed in class 10th and how to find their values. Now the question arises, if we have to find out T ratios of angles like 120 degree, 150 degree and any higher angle 390 degree, so on 1200 degrees, etc. So we make use of the basic concepts of these allied angles. Angles of the type of minus theta, 90 degrees plus or minus theta, 180 degrees plus or minus theta, 270 degrees plus or minus theta, 360 degrees plus or minus theta, dash so on. We term this type of angles as allied angles. Now in this case, the difference of any two angles is a multiple of 90 degree. When we discuss the multiple of 90 degrees, we have multiples 90 degrees. Well children, we are familiar with the set of natural numbers as 1, 2, 3, 4, 5, 6, dash, 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 so on. And in the lower classes, we have done the tables of different numbers. For example, tables of 5 as 5, 10, 15 and so on. This is a multiples of 5. Nutshell, if we want to write the multiple of any number, so we have natural numbers, multiply each natural number by that number. Multiples of 6 are 6, 12, 6 into 3, 18, 6 into 4, 24 and so on. So, multiples of 90 here, if we have these natural numbers and multiply each natural number by 90, so we get 90 degree itself, 2 into 90, 180 degrees, 3 into 90, 270 degrees, 4 into 90, 360, 5 into 90, 0, 6 into 90, 540, and so on. Here at this stage, we categorize as odd multiples of 90 degrees and even multiples of 90 degrees. Now here we observe, if you multiply the odd numbers 1, 3, 5 natural numbers by 90, we get odd multiples of 90 degree. 1 into 90, 3 into 90, 5 into 90 and so on. और अगर हम इवन नेचुरल नंबर्स को 90 से मल्टीप्लाई करें, so we get 2 into 90, 180 degree, 4 into 90, 360 degree, 5 into 90, no, even number is 6, 6 into 90, 5, 4, 0, and yes. So till this stage, we need to make emphasis on the odd multiple of 90 degree and even multiples of 90 degree. So making use of this, we shall have the rule first. Rule first is when an angle theta is 2 or subtracted from an odd multiple of 90 degrees, that is 90 degrees, 270 degrees, 450 degrees and so on. The trigonometric ratios, in short I wrote T ratios, trigonometric ratios, are changed into their respective co-ratios. Lay stress on this co-ratios and the sign into their respective co-ratios, and the sign is attached by all sin, tan, cos regarding theta to be an acute angle. Now, when we talk of this odd multiple of 90 degrees, we have 90 degrees plus or minus theta, 270 degrees plus or minus theta, 450 degrees plus or minus theta if you have an angle like this. We are familiar with the 6 trigonometric ratios: sin theta, cos theta, tan theta, cot theta, secant theta and cosec theta. Out of these 6 trigonometric ratios, there are 3 trigonometric ratios which start with the letter C, C for cos, C for cot, C for cosec, and the other 3 trigonometric ratios, sin theta starts with S, secant theta with S and tan theta with T. Now, these are the 3 trigonometric ratios, namely sin theta, tan theta and secant theta. We start with the letter either S or T. If we attach CO with this, before sin we write out cos, it becomes cosine theta, that is cos theta. We say that co-ratio of sin theta is cos theta. And if we remove CO from here, that is this, it becomes again sine. So, co-ratio of cosine is sin theta. Likewise, co-ratio of tan theta is cotangent theta and co-ratio of cotangent theta is tan theta after having removed CO. Likewise, secant theta has the co-ratio cosec theta, and if we remove CO from here, it is secant of theta. Well, at this stage, the students are confused with reciprocals. Well, reciprocal is sin theta multiplied by cosec of theta equals to 1. Reciprocal of sin theta is 1 by cosec theta and cosec theta equal to 1 by sin of theta. Well, here at this stage we say that reciprocal of sin theta is cosec theta, 1 by cosec theta, and reciprocal of cosec theta is 1 by sin theta. But here if you see sin theta, its co-ratio is cos theta, cosine theta, but its reciprocal which we have read in class 10 is cosec of theta. Similarly, tan theta equal to 1 by cot theta and cot theta equal to 1 by tan of theta. Here in this case, reciprocal of tan theta is cot theta, and of course in this case co-ratio is same. Then cos of theta, its reciprocal is secant of theta, and secant theta to 1 by cos of theta. In two cases, cos theta and sin theta, we have different reciprocals. So, compare them. I once again introduce you with the co-ratios. Co-ratio of sin theta is cosine theta, and if we remove cos theta, co-ratio of cosine theta is sin theta. But reciprocals are different. Reciprocal of sin theta is cosec theta and reciprocal of cosec theta is sin theta, but it is different in case of co-ratios. I hope it must be clear, and while writing you should learning this co-ratios, you compare reciprocals with this. Then, and the sign to be attached is governed by the rule here, all sine, tan and cos. That is all sine, tan and cos. Well, in this case we have all trigonometric ratios are positive in the first quadrant, sin theta is positive in second quadrant, tan theta is positive in third quadrant, and this is fourth quadrant. If you consider the first letter in each case, A, S, T and C. So, in a very crude way, we can, A stands for add, S for sugar, T for 2 and C for coffee. Well, to prove this or to establish this, we consider this is y axis and x axis, x, x dash, y, y dash, and this is origin. This is the first quadrant, we move in the anti-clockwise direction. This is second quadrant, this is third quadrant and this is fourth quadrant. When we say all trigonometric ratios are positive in the first quadrant, we draw this right angle triangle. M1 would stand for the first quadrant. This is a right angle. Consider this angle as theta. So, we have here P1. So, this is a right angle triangle OM1 P1. OM1 lies along O plus X and this is to be taken as positive. P1 M1 which is parallel to O plus Y, this is to be taken positive. And this revolving line OP1, by convention this is always to be taken as positive. This is a mathematical convention. Well, students studying for the first time would find it difficult to understand the word convention. I give you an example. Convention is a rule which you adopt. Rule of the road is keep to the left, and that is our convention. If you go to Europe, we have a convention keep to the right. Here we have a mathematical convention that this revolving line OP1 or any revolving line in the first quadrant is always to be considered as positive. In this first quadrant, if we take up sine of theta, this is perpendicular upon hypotenuse OP1. This is positive, this is also positive. If you divide one positive number by another, you get the result as positive. So, sin theta is positive. Likewise, if you take cos of theta, this is base upon hypotenuse. So, this is positive, this is positive, the result is positive. And if we take tan of theta, this is P1 M1 upon O M1, both are positive. So, this is positive, the result is positive. That means if this angle theta lies in the first quadrant, then all the trigonometric ratios are positive. Now here comes, in case of reciprocals, if sin theta is positive, obviously cosec theta will be positive. It's reciprocal. If cos theta is positive, then secant theta is also positive. And here in this case cot theta is positive. So we conclude here that all trigonometric ratios in the first quadrant are positive. When we say in the first quadrant, that means any angle lying between 0 and 90 degree will have the trigonometric ratios as positive. Then we move to the second quadrant. In second quadrant the angle is like this. Now the revolving line OP2 upon M2. OM2, this is M2, is negative, this is positive, and this is always to be regarded positive, this revolving line. So if you find the trigonometric ratios in second quadrant, sin is positive, that is P in second quadrant here, sin theta is perpendicular upon hypotenuse. So this is positive, the result is positive. If you take cos theta, this is OM2 based upon hypotenuse. So this is negative, this is positive, the result is negative. And tan of theta equals to P2 M2 upon OM2, and this is positive, this is negative, the result is negative. Well, in second quadrant sin theta is positive, and obviously its reciprocal cosec theta will be positive. Cosec theta is positive. And if cos theta is negative, its reciprocal secant of theta is negative. Its reciprocal cot of theta is negative. In third quadrant, we have the figure like this. This is a right angle. This is to be regarded positive. This is negative. So in third quadrant, sin of theta is perpendicular. This is OP3. This is M3. P3 M3 upon OP3. So this is negative, this is positive, so sin theta is negative. Cos theta is OM3 divided by OP3. So this is negative upon positive, the result is negative. Then tan theta P3 M3 upon OP3. P3 M3 is negative, this is also negative, the result is positive. So, in third quadrant tan is positive, other trigonometric ratios sin theta and cos theta are negative. Well, of course, here reciprocal of sin theta, that is cosec of theta, is negative, secant theta is negative, and cot of theta is positive. We finally come to the fourth quadrant. In fourth quadrant, we have a figure like this. OP4, this is M4 here, it's a right angle. This is a revolving line is always to be taken positive. P4M4 is parallel to Y dash is negative. So, if you take into consideration this fourth quadrant, sin theta is negative, cos of theta it is positive, and tan of theta is negative. If secant theta is positive, its reciprocal secant theta is also positive. Cosec theta is negative. Cot theta is negative. Well, I can write here cot of theta is, oh no, cos theta. This is cos, theta is positive. So, nutshell, when we say all sin, tan, cos, all trigonometric ratios are positive in the first quadrant, sin is positive in the second quadrant. Well, its reciprocal, that is cosec of theta will always positive in second quadrant. In tan theta, cot is positive, and in fourth quadrant secant is positive along with cos theta. So, we observe here whether it is a second quadrant or third or fourth or first quadrant, all trigonometric ratios are positive in the first quadrant. That means, if you take sin theta, it is positive in two quadrants. Sin of theta is positive in first and second quadrant. And negative, sin theta is negative in third and fourth quadrants. In other words, every trigonometric ratios is positive in two quadrants. Cos of theta is positive in first and fourth. Cos theta is negative in second and third. Tan theta is positive in first and third. Tan theta is negative in second and fourth. So, we observe here every trigonometric ratio is positive in two quadrants and negative in two quadrants. So, if sin theta is positive in first and second, it is obvious it is reciprocal. Cosec theta will also be positive in first and second and so on. Having learned the first rule, we make use of this in finding the trigonometric ratios of the angles higher than 90 degree. Now, for instance, we want to find out cos of 120 degrees. So, I can write it as cos of 90 degrees plus 30 degrees. So, this is 120 degrees. Now, here we observe 90 degree is a odd multiple of 90 degrees. Odd multiple of 90 degrees, I have already explained you odd multiples of 90 degrees or 90 degree itself, 270 degrees, 450 degrees and so on. So, we make use of the first rule which says that if you add angle theta, theta stands for 30 degree here, this trigonometric ratios outside this bracket cos changes its co-ratio. Now, we find the co-ratio of as sine, yeah, it is cosine theta, co-ratio is sine. So, it changes into sine theta. Then angle to be attached, sine to be attached is determined by the rule all sine, tan and cos. Now, I want to know where does the angle 90 degree plus theta lies, 30 degree lies. Starting from here, we have 90 degree plus 30 degree. So, this is the second quadrant, where second quadrant sin theta is positive, but this ratio which we are going to find out is negative. So, instead of theta we have 30 degrees. So, this is minus 1 by 2 because sin 30 degrees is 1 by 2. Tan of 120 degrees, I can write down as tan of 90 degree plus 30 degree. Again 90 degree is odd multiple of 90 degree. So, this tan changes into its co-ratio cot of 30 degree. Now, it lies 90 degree plus 30 degree lies in the second quadrant where it is negative. So, this is minus root 3. Then sine of 120 degree. So, this is sine of 90 degrees plus 30 degrees, which is cos of 30 degrees, and cos 30 degrees 90 degree lies in plus 30 degree lies in the second quadrant. Here I explained you. So, it is positive because sin theta is positive in the second quadrant. So, this is value of cos theta is under root 3 by 2. We take another example. For instance, we take cosec of 150 degrees. So, this can be written as cosec of 90 degrees plus 60 degrees. If you add 90 and 60, it makes 150 degree. Again 90 degree here is odd multiple of 90 degree. So, cosec changes to co-ratio and this co-ratio is secant. ये co-ratio of cosec is here, co-ratio of cosec is secant of 60 degree, and secant of 60 degree is 2. If it is cos of 150 degrees, this is cos of 90 plus 60. So, this cos will change into its co-ratio sin 60, and in second quadrant cos is negative, and this is minus root 3 by 2. Now, for instance, we want to find out tan of 210 degrees. This is tan of 270 minus 60. Now, 270 degrees is again odd multiple of 90 degrees. So, tan of co-ratio is cot of 60 degrees, and it lies in the third quadrant. See how? This is your y-axis, this is x-axis. Revolving line always starting from O plus x. 270 degree, 90 plus 90 plus 90, 270 is minus 60. If it is plus 60, we shall go forward, but if it is minus, we will move backward. So, 270, this revolving line lies in third, where tan is positive in third quadrant, and cot 60 degree is root 3. Ultimately, the value of tan of 210 is root 3. Let us find out secant of 225 degrees. Now, this can be written as secant of 270 degrees minus 45, which is equal to cosec of 45, lies in third quadrant where secant is negative. So, this is minus 1 by root 2. Let us find out cot of 330 degrees. Now, this can be written as cot of 330, 270 plus 60, or this is equal to minus tan of 60. This is negative, cot is negative because it lies in the fourth quadrant. This is y-axis, x-axis starting from here, 270 plus 60. So, this is minus root 3. Well, in our last lecture, we obtained the values of 150 degree angle, 210 degrees angles, 330 degree angles, trigonometric ratios of these angles by making use of odd multiple of 90 degree. Now, we have a rule second where we shall make use of even multiple of 90 degrees. The rule states like this: when an angle theta is added to or subtracted from an even multiple of 90 degrees, that is 180 degrees, 360 degrees, etc. The T ratios suffer no change. Suffer no change. And the sign to be determined sign to be determined and the sign to be determined by the rule all sin tan cos. Regarding theta to be an acute angle. Well, here the rule states that when an angle added subtracted from even multiple of 90 degrees. Now, for instance, I want to find out sine of 150 degrees, cos of 210 degrees, cos of 120 degrees, tan of 210 degrees, secant of 330 degrees. So, we can make use of the even multiples of 90 degrees, that is sine of 180 degree minus 30 degrees. I can write it as cos of 180 degrees plus 30 degrees. I can write it as cos of 180 degrees minus 60 degrees, cot of tan of 210, 180 plus 30. This is secant of 360 minus 30. Now, we observe here 180 is even multiple of 90 degree. This is also even multiple of 90 degree, even multiple of 90 degree and even multiple of 90 degree. So, no change in T ratios. It remains sin 30 degree, it remains cos 30 degrees, it remains cos 60 degrees, it remains tan of 30 degrees, it remains secant of 30 degrees. But the sign depends upon the quadrant in which each one of these angles lie. Now, for instance, we have say 180 minus 30 starting from O plus x in first case. This is 180 minus 30 degree backward. If it is plus 30, we go forward. If it is minus 30, we go backward. So, this is the second quadrant. So, in second quadrant sign is positive. So, we have positive. Then this is 210. Again y axis, x axis, starting from here 180 plus 30. The third quadrant, in third quadrant cos is negative. Then 120 degrees. This is third case, 180 minus 60. So, in second quadrant again cos is negative. Tan of 210, this is third quadrant, and tan is positive in the third quadrant. 360 minus 30, this is 360 is complete rotation, minus 30 backward. In fourth quadrant secant is positive. So, this. So, now you can write down the values. Sin 30 degrees 1 by 2 minus root 3 by 2 minus 1 by 2 cos 60. Tan 30 is 1 by root 3, and this is 2 upon root 3. Well, it becomes very interesting if we make use of odd multiple of 90, as in the last example we had sine of 150. Now, this can be written as sine of 90 plus 60. So, if you compare, it is 180 minus 30 gives you 150. Here 90 plus 60 gives you 150, but the difference is that of the multiple of angle 90 degree. It is odd multiple, odd multiple of 90 degrees. So, in this case sine will change into its co-ratio cos of 60 degree, and it lies in the second quadrant where sine, this is to be seen, is positive, and cos 60 degree is 1 by 2. Whether you make use of the even multiple of 90 degree here or the odd multiple of 90 degree here, we observe the answer is the same. I take cos of 120 degree again. I shall make use of the odd multiple cos of 90 degree plus 30 degree, 120 degree. So, this is odd multiple of 90 degree. So, this will change into co-ratio sine of 30 degree. It lies in the second quadrant, 90 plus 30, 90 plus 30. In second quadrant it is negative. Finally, the answer is minus 1 by 2. So, whether you make use of 180 degree minus 30 degree or you 90 degree plus 60 degree, answer in both the cases same, 1 by 2 here, 1 by 2 here. It is for your choice to see to it whether you have to use even multiple of 90 degree or odd multiple of 90 degree. I give you more examples on this. Now, after having made use of the even multiples of 90 degrees, we talk of the periodic function. All trigonometric ratios, all trigonometric all trigonometric functions or periodic functions. All trigonometric functions are periodic functions. That is, they repeat their values after a fixed interval. This fixed interval is called the period of the function. Periods of sine of theta, cos of theta, cosec of theta, and secant of theta is 2 pi. Sin theta, cos theta, cosec theta and secant theta is 2 pi, whereas period of tan theta and cot theta is pi. However, all t ratios repeat their values, after an interval of 2 pi. For example, sine of theta has same value as sine of 2 pi plus theta, has same value sine of 4 pi plus theta equal to dash dash so on sine of 2n pi plus theta. Then cos of theta has cos of 2 pi plus theta, cos of 4 pi plus theta to dash dash so on cos of 2n pi plus theta. Then tan theta equal to tan of pi plus theta, tan of 2 pi plus theta, tan of 3 pi plus theta dashed as so on tan of n pi plus theta, etc. Now, we make use of this property of sporadicity in finding the values of the trigonometric ratios. For example, sine of 480 degrees. So, in this case we have 480 degrees to be divided by 360, because all trigonometric ratios this repeat after an interval of 2 pi. So, this is 3, 6, 0, 0, 2 and 1. So, I can write this as sine of 360 degree plus 120 degree. So, we make use of this result, sine of 2 pi plus theta has same value as sine of theta. So, this is theta here stands for 120 degree. Mind it, in this case we have not to make use of the rule. Note it. This is the property of the periodic function. Now, next we find the value of sine 20 degree. As usual, sine of 180 minus 60, or this is equal to sine of 60 degree, which is root 3 by 2. In nutshell, I will say that sine of 480 degrees is under root 3 upon 2. I shall take more examples like this. Let us find the value of tan of 1215 degrees. As usual, we divide this by 360. So, this will go by 3, 1080, 5, 3 and 1. Now, this can be written as tan of 3 into 360 degree plus 135. We use of this periodic function property. So, this is equal to tan of 135. As we have tan of n into 2 n pi plus theta is equal to tan of theta. It is tan of 3 into pi plus theta is tan of theta. So, if it is tan of 3 into 2 pi plus theta, so this is also equal to tan of theta. Basically, I may use this result. So, this is tan of 180 minus 45, which is equal to tan of 45 degree, no change, and 135 degrees lies in the second quadrant, 180 minus 45. So, this will be negative and this is equal to minus 1. However, the tan of 135 degree can be obtained as tan of 90 plus 45. So, this will be equal to minus cot of 45. Again this is minus 1. The choice is yours, whether you make use of 180 minus theta or odd multiple of 90 plus 45. I take more examples on secant of 390. Now, this can be done as secant of 1 into 360 plus 30, which is equal to secant of 30 degree, no change, and secant 30 degree is 2 upon root 3. Then we have angles like this, cosec of minus 2025. We shall make use of this result. Sine of minus theta is minus sine theta, cos of minus theta is equal to plus cos of theta, tan of minus theta is minus tan of theta, cot of minus theta is minus cot of theta, secant of minus theta is plus secant of theta, this is also plus, and finally cosec of minus theta is minus cosec of theta. There is a specific geometrical proof for this, but to remember we make use of this figure, this is y-axis, x-axis. If the angle is positive, we shall move in the anti-clockwise direction, but if the angle is negative, we move clockwise direction, and this is minus theta. This is the first quadrant, second quadrant, third quadrant and fourth quadrant. To just memorize this result, in fourth quadrant we have cos of minus theta positive, secant of minus theta is positive, but there is a specific geometrical proof in this, irrespective of the fact that this angle minus theta lies in any of these quadrants. We make use of cosec of minus theta, that is minus cosec of theta. Theta in this case is 2025 degrees. We divide this 2025 by 360. This is 5, 2 and 2. So, I can write this as minus cosec of 5 times 360. This is quotient into divisor plus remainder 225. So, this is equal to minus cosec of 225, or this is minus then bracket cosec of 180 plus 45 in third quadrant, and this is minus cosec of 45. This minus and minus becomes plus, it is root 2. We can take up more examples on this. So, this can be written as tan of 13 by 3 into 180 degrees. Pi radians equal to 180 degrees. Change into degrees. So, this is equal to tan of 60, 780. If you simplify, 780, which can be written as tan of 720 degree plus 60, that is tan of 2 into 360 plus 60, or this is equal to tan of 60, which is equal to sin 60 upon